Okay, let's continue. Okay, so in order to illustrate the significance of the discriminant delta and thus the classification of PDE equation number 2. Okay, so to get the illustration means some graphical idea as well as the classification. We try to reduce the given equation to a canonical form. Okay, canonical form. Okay, let's see what is the how we can get the canonical form. Okay, for that, to do this, we transform the independent variable. So what are the independent variable we have taken in our equation number 2? So I told you the u is dependent to independent variable x comma y. No, so x and y. So we are going to transform this independent variable only. Okay, x and y to the new independent variable. Okay, so because that's what we are doing as a coordinate transformation. Okay, so try to write this correctly. This we call it as theta and neta. Okay, so in all the books and all the people, they use this notation. So try to write this notation. So hope you may use somewhere, or you can try to do. So like this, theta and n, and like this. This is a neta. Okay, so practice this notation also, because that's what we're going to use for here. Okay, for the x, okay, theta and neta through the change of variables. Okay, so what I'm gonna do is I'm gonna transform my independent variable x and y as, so the theta will be, which is equal to theta of, okay, theta of x comma y. Okay, also neta as neta of x comma y. Okay, we call it as theta neta. Okay, okay, you can take this one as a equation number 3. Yeah. Okay, let me continue. So if you are slow, please take down the screenshots. Okay, now where, so I need to talk about the theta neta now. Theta, okay, theta and neta are twice continuously differentiable. So that is one of the conditions. Okay, what that says is, so even though I'm taking the theta is equal to theta of x comma y, neta also neta of x comma y. Okay, so I have taken my new coordinate which is dependent on my earlier coordinate, earlier independent variable. Okay, this is also new independent variable which I gonna transform, but that is also dependent on x and y. So that's what the idea. Okay, also because you know we are dealing with the second order PDE, so it should have, it's not like it should have to twice continuously differentiable. Okay, otherwise it will be even if you take something, if it is a constant, let's say, so if you take the first daba or daba, it will be 0. No, then there's no work for second order or anything. No, we can't transform. So we have to make sure it is twice continuously differentiable. Okay, and also So tell me about the in the vector calculus. When we transform from one coordinate system to the other, what actually we have checked? Do you remember? What is the conditions? So if you, let's say, rectangular coordinates to polar coordinates, or spherical coordinates, okay, any curvilinear coordinates, what is the condition to be satisfied? Anyone? Do you remember? So you also studied vector calculus as well as, yes, good. One of the person answered. So what is that? Give me the full condition. In the vector calculus as well as you also studying the other one also, no? Geometrical. Differential geometry also you have studied that thing. So if you wanted to transform one coordinate to other coordinate, there's one condition should be satisfied. Yes, give me the full. You're just giving the name of that. Okay. Yes, you are giving that Jacobian. Okay. What is the Jacobian? Jacobian should be what? Is that equal to 0? Are you sure? If Jacobian is equal to 0, can you do that? Or not equal to 0? Which is that? Yes, good. I hope you got remembered. Okay. Jacobian should not equal to 0, isn't it? So that's what also applicable here. Okay. If I am transforming xy to the another theta neta, that is also should be obey this Jacobian. Okay. So the Jacobian in the sense, so you can write here Jacobian. So Jacobian we know, no? Dabba of, if I am taking theta neta, so I need to partial derivative x comma y, which is equal to, so I'm going to write dabba theta of dabba x and dabba theta dabba y, again dabba neta dabba x, dabba neta dabba y. So I'm going to use these notations. Okay, that is theta x, theta y. Okay, so neta x, neta y. Okay, so it should be not equal to 0. Then only I can do the transformation. Okay, so you can write this as a equation number 5 in the given region, isn't it? Region under consideration. So you have, it should be satisfied under some and the region have given. Okay, considerations. Okay. So from this, what we are concluding is, if Jacobian not equal to 0 means we can transform. So I don't need to write about this. So you may have. Okay. So that means I can use my new independent variable as a coordinate for my old equation number 2. Okay. So when I am getting this not equal to 0, I can make sure I can transform my earlier independent variable to my new independent variable. Okay. So that's what it says. Okay. Now, so let me continue. Okay. So let's continue. Okay. Now we let's put a small heading. We're gonna introduce a new independent variable. Okay. So what is our new independent variable? For the x comma y, I'm gonna transform theta x comma y. Okay. Neta x comma y. Okay. As a coordinate. This coordinate to this coordinate. Okay. Then what about my dependent variable? Ux comma y can be written as u of theta x comma y. Wherever x I can put theta, isn't it? Wherever y I can put neta. Okay, That's what it says. Also, these are a function of that independent variable. Okay. So if you are having like this, okay, even in the vector calculus, we have used some one of the rule which called as a chain rule. Okay, I hope you remember this one. Okay, so that's what we're going to use it. Okay, to get our what is ux, uy, uxx, uxy, uyy. We need for in our equation number 2, no? So here we are taking u as a function of zeta, that is zeta depends on x. So it is like this. U is a function of, I'm just explaining, okay? This is depend on eta and zeta. But actually this zeta is depend on x and y. Similarly, this one, x, y. So if I wanted to get this one to this one, I need to come here to here, no? That is what we called as a chain rule. Also here to here, okay? So this is we called as a chain rule. So you can use this, pictorial view to get it correctly. Okay. So even whatever the number of things, you can use this pictorial view to get our chain rules. Okay. So I'm gonna do the derivation. So please write with me, possibly. Okay. Maybe the windows I need to change. So please write quickly. Okay. So then, okay, and apply, write down, and apply the chain rule to compute the terms of the equation number 2 in terms of zeta and eta as follows. Okay, so we have taken u is a function of zeta x comma y and eta x comma y. Okay, please write down correctly. Okay, anyhow you should show the differences between zeta and eta even in the exam also. So just practice it carefully. So don't just mix up the things, or don't write this. Okay, so write carefully and show the differences. See, in my writing you can see this is eta, this is eta. That's how in your writing. So you don't need to write neatly, but it should be differentiable. Okay, so what if I take ux? So it means what? I need to take daba zeta over daba, x time, sorry, daba u over zeta into daba zeta over daba x. No, this is our chain rule. Okay. Okay. So actually u is dependent on eta x. Sorry, give me a second. Okay, u is dependent on zeta x and eta x. Okay, so you have to be carefully consider that one. So this will be plus daba u over daba neta times daba neta over daba x. Did you understand? So since u is dependent on eta and zeta, sorry, zeta and eta. Okay, so if you are taking the x with respect to x, you have to go to the first of all zeta and then zeta to x. So this is how it comes: u zeta neta. Okay, this is x, this is y, this is x, this is y. So I need to go this and this and this and this. Okay, so I need to go both way to get the x. So if I write nicely, so I'm going to use the notation. Okay, into zeta of x, okay, plus u neta times neta x. Okay, so I'm not going to write these things again. Okay, this idea, you can have one line and you can fill it, okay, according to this knowledge of chain rule. Okay, similarly uy, you can have one space, you can write this one, and the answer will be u zeta y plus u neta y. Okay, I'm taking with respect to y. Okay, this is our first orders. Okay, how about the second order? Second order has some extra works, no? Okay, let me take down. Okay, I'm taking the next window. Okay, now what about the UXX? So there in the UX, we had so I'm just writing, okay? Theta x, no need to copy yourself. Neta x, okay? So see here, I need to take this term plus this term. So let's take for the first term, okay? So theta will be u theta. So you just write the first line. I'm writing the second line, okay? Times theta x, okay? Okay, for this one, okay, what I'm doing is for the u theta will be u theta times theta x, no? Like for example, what if you have e to the power 2x or let's say x squared? So if I wanted to take the d over dA, first of all, I need to take full function. And then I go for inside the function 2x, no? Did you understand? So that's what happening. First of all, I'm taking u theta, then zeta x. Okay. Already there is a theta there, no? So that theta x also coming. Plus, okay. And I'm gonna, this is like a UV form. Okay, UV form. So for example, let's say if I have x squared and let's say sine x. Okay, if I wanted to take the d over dx, first of all, I need to take x squared into cosec plus again this v into sine x into 2x, no? So that's what I'm doing. Okay, first I have taken for this one with this. Okay, there's other one terms comes. Next one I said 2x. Okay, I mean u terms there. For the v term, if I take again x, okay. So I'm writing first of all, you write the actual way, and then I'm writing the second term. You also understand it, okay? Next one, also you have to know this u is already have the theta, neta. So whatever I'm doing for theta, neta also depend on x, no? So I need to go for neta also. So for this one, u, okay, theta, neta, okay, like this, I need to take theta, neta, and then neta x, also theta x there. So I can write like this, I think. So plus u theta x. So this term and this term for only this term. Okay, second derivative. Okay, give me a second. Okay, I'll change the color so you understand. Okay, so for this term, I have written this full. Okay, and then for the UV form, this is U form, this is a V form. Okay, so if I take U, this V, for the U, if I take second derivative, I have this plus this, because U is already dependent on theta and neta, so I can't left out. Okay, first of all, I need to take with respect to theta, and whatever I'm doing, I need to also do for the neta, because it depends on two variables. Okay, so you just check again. So this is all for this term only. So let's say my term will be 1. Okay, so this is my term 1. So this full term will be for 1. Okay, so I need to do again the same thing for the second term. Let's say this is my second term. Okay, so this, so I don't know you can see or not. Okay, second term plus. Okay, what for the, okay, take down this one. U neta x. For this term, okay, second term, I need to take same thing. Okay, so see here what will happen. First of all, it is also like a UV form. So I need to take u neta, okay, sorry, yeah, neta and neta times x. Okay, this is for u term. Then v term will be there as it is. Okay, so you can use pencil or something to write what I am writing. This is u, this is v, plus. Okay, so you also depend on, if it is neta, you have to also take the theta also. So neta first, then again I need to take for the u neta, I need to take u neta as well as u neta theta also. Okay, so you can write this one here or this one there, but for the easiness I'm writing this way. Okay, if I am taking neta z, okay, neta zeta, okay, then I need to take theta x times, but my v term will be neta x. Okay, hope you understand. So this is my second term. So what is my second term? This is all for the u term. Then v term will be u neta will be as it is. Neta only I'm gonna take x times xx. Okay. Yeah. So I'll write again. Okay. For the need. I'll write neatly, which is equal to u xx is equal to u theta x, okay, plus u theta neta and neta x, okay, I'm just writing for your understanding, okay, u theta times theta xx, okay, this is for first term, this is for the u term, this is for the v term. Similarly, there is second term. This is all for the first term. Second term, u neta neta x times neta x plus u neta zeta x times neta x. Okay, plus u neta times neta xx. Okay, so what happening is this is the u term of second equation. This is the v term. Okay. So when you are writing the uv form, you also, for example, e to the power ax plus sine bx. So what do? You keep this e to the power ax, then find this one, cos bx times b. Okay, again, sine bx as it is, and then you are taking e to the power ax. Again, a also you have to take. So that's what is happening. Okay, you just understand. You again write and understand yourself. That's what I have done. Okay, please write these notes also somewhere, so you may know, you may compare the answers. Okay, so if you are taking, this will be v terms. See, this is my v terms, so I am taking only for the d of u term. Okay, again, this is since it is depend on u zeta neta, I'm taking 2 times. Okay, see, my this term will come like that. Again, so you can also write like this. So commonly you can put like this also. So theta x, something like that. Okay. So yeah. So I'm taking that one because some purpose. Okay. So let's simplify this one. For example, see here theta x. So I can write theta x squared now. Okay. So theta x squared. Okay. Plus next one, u zeta neta. So that's what I told you to write carefully. Zeta neta, you have to show the differences. Okay. Sometimes some people write theta also like this, neta also like this. So we can't find the differences. So people put wrong. Okay. So you have to be carefully write the things. So if you practice, it will come. Okay. Yeah. See here, this one and this one. I'll use another color. Please follow me. Okay. Otherwise, it will be very hard. So this term and this term, what do you think? Zeta x there. Neta x there. So this is u zeta neta. This is u neta zeta. So I told you, no, even uxy is equal to uyx. Similarly, this is applicable for here also. So I can take this as a common one. So I can put 2. Okay, so I'm adding this term and this term as a same. Okay, plus the rest of the term. So let's write this one first. Okay, u neta 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 x. So neta x is square. I can write as a, okay, give me a second. Yeah, so since here the same times comes, so neta x is square plus this term is there, this term is there. So I can write u zeta zeta x plus u neta neta xx. Okay. So this is our equation. Yeah, we are not finished now. This is only for the uxx. Okay, if you understand this, okay, so all the other terms, since, okay, I'm continuing. Can you take this one, screenshot or anything? So otherwise, write down quickly. So we have 10 minutes. So yeah. So if you understand that one, so since in our equation number 2, we have uxx there, uxy is there, uyy there, all the other term we are taking as a pi now. So you have to get this one, this one, this one. Okay. So I got this one. So use the same idea to get the other one. I just writing the last answer. Okay. See whether if you're having any trouble or anything, you can ask in the next class. But I hope you don't get. Okay. You also can refer some books. So videos to understand it, but I'm writing only the answers. Okay. So u zeta 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 y square, since I'm taking y, okay, plus again 2 times, so you can get the same things. Okay, zeta y neta y. Okay, next term will be u neta 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 y square. Okay, plus u zeta zeta y plus u neta neta y. Okay, so same things, only thing is we are taking y again. Okay, if you write the uy and then you take the second derivative. Okay, similarly I don't need to find ux y y z, no, only things. Okay, so this one little bit critical, but check it. If you understand the concept, this idea, it is same idea applicable. Okay, so I'll write down the final answer. Please make sure to put some spaces for you to derive. Okay, I'm just writing the final answer. Or otherwise, you can write this in the rough or somewhere and you can write nicely later. U zeta x zeta y plus u zeta neta. So see whether my zeta and neta are different. Okay, so don't confuse yourself. This is a zeta. Okay, I'm writing a little faster so it comes like that. And zeta x neta y plus neta x zeta y. In this case, we can't add these two. So we will find a common element outside and these two terms like this. Okay. The third term will be u neta 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 x neta y plus the rest of the terms are u zeta zeta xy plus u neta neta xy. Okay. So totally you can put as a equation number. What is the number? I think put the Jacobian as a equation number 5. So it will be 6. Okay. So coordinate transformation, little bit, it takes time to understand, but it's not a big thing. If you understand correctly, this is a partial differential. So it need to consider x and y terms. And when you're taking the x, you have to take the y as a constant and things like that. Okay. So, but here theta and eta are function of x and y. So it will not vanish. It will come like that way. Okay. Okay, let me continue and finalize. So I think today is a Friday, no? So I need to finish now. Okay, shall we finish now? And we can, okay, what you do is you just substitute. I will finish up here, okay? Substitute these expressions of equation number 6 in equation number 2, okay? Okay, wherever uxx, you substitute. Uxy, you substitute. Uyy, you substitute. Okay. All the other term you write as a any pi. Okay. Pi as a new data. I mean zeta, neta for the wherever the xy comes. Okay. So you're gonna substitute this one, whatever we find. Okay. So the equation number 2, you know, xx, axx, I mean bxy, cyy, isn't it? Use uyy, which is equal to pi or something I told you. Okay. So here what you do is a time, whatever you find, write down. Maybe it's a big one, but write down. Okay. And b times whatever we find as a zeta neta. Plus c times zeta, whatever we find. Plus here this function depend on x, y. I told you x, y and ux. I mean u and ux, ui, no. So since we are transforming this, put another variable as zeta, neta, and for the u, and for the ux, you can put u zeta, u neta. Okay, which is equal to 0. This is our equation number 7. Okay, so after that, you take what is u zeta zeta. This is your homework. Okay, we can continue from this next week. Zeta neta, what is the coefficient of u neta neta plus these functions. Okay, so this is your 8th equation. Please derive this one and we can continue in our next lecture. Okay. Okay. I'm finishing here. Take care. So, second. Did you get this? Please take the screenshot I took quickly. Okay. I'm closing now. Please take the screenshot. So this is your homework. Please drive up to the equation number 8. Okay. Just you write whatever you are going 8 times something you will get. Okay. Okay. I'm stopping now. Okay. Have a good day. Bye.